Okay, so now we've graphed this parent, and now let's see what happens. Okay, so now you can see we've changed the equation again, and it's up here. So it says y equals x squared plus q. Now q is going to be a number that's going to change. Okay, now what we're going to really do is we're going to compare our parent, which is y equals x squared, and you can see it says plus q, so we have the parent, plus we're doing something else to it. So the first thing I'm going to do is I'm going to draw this parent. Okay, so we know the parent has the vertex, and you're going to be doing this a million times. So I'm going to put the parent down again. It has a vertex of 0, 0, and I need to know that because that's my starting point. I know its step pattern is, so I'm going to put it here, so I have an over and up. And you're saying it's just on the other page. I know it's on the other page, but this is so important. Over 1, up 1, back to the vertex. Over 2, up 4, back to the vertex. Over 3, up 9. So I'm just going to very quickly draw that, because you saw me take my time and draw it on the previous page. And this time I'm going to do my best to join them together half decent, because it'll make your life a little bit easier to see. As I said, it gets a little wonky. Okay, so not too bad. So that is the parent graph. Now what I want to do is I'm just going to first of all make this stay still, and I'm going to join those points up on that graph. So I'm just going to group them. Okay, so I believe they're all grouped. Yes, they're grouped. Okay, now the reason I'm grouping them, because if I look at the first one that we're asked to kind of look at, and I'm going to do that one in green, it says y equals x squared plus 5. So really what's happening here is we're taking the parent, and you can see that the parent's in there. There's the parent right there. And then what they're doing is they're adding 5 to it. Okay, so we're literally taking every single y value and adding 5 to it. So if I did that, then this point that's at 0, 0 will become 0, 5. Oop, wrong pen. Did all that work and it would disappear on me. So it's here. This one here, this point here gets moved up 5 too. 1, 2, 3, 4, 5. This one here gets moved up 5. So everything gets moved up 5. And which is kind of cool in a sense. Uh, Now, just hold on a sec. Now, that's not usually how I graph it, by the way. 1, 2, 3, 4. And I can't get the last ones. Will be up 5, which would be at 15, which is off our grid again. Okay, so there's those points. And if you actually see me, again, pick up the parent and put it in place, you can see that it's the same shape. It's the same shape. It has the same kind of step pattern, which is very important. Okay, because I don't want to have to draw this parent every single time. Okay, but I can, and you can see that it is the same shape. So all that did by doing y equals x squared plus 5 is it moved the whole graph up 5 spaces. So in a sense, what really happened there is the vertex changed, and it changed, so now it's at 0, 5. So the vertex is at 0, 5, but let's look at the step pattern. From the vertex, over 1, up 1, back to the vertex. Over 2, up 4, back to the vertex. Okay, so the step pattern stayed the same. So that's kind of nice to know. So it means if I could find the vertex, I can just apply the same step pattern and I can graph it. Now, what do you think would happen if we look at this one? So if I look at y equals x squared minus 2, again, you can see that the parent is right here, y equals x squared, but this time everything is going down 2, so it's minus 2. So my vertex then would be at 0, negative 2, and instead of actually moving everyone down 2, I'm just going to use the step pattern. So I'm going to start at 0, 2, over 1, up 1, back to the vertex, over 2, up 4, 1, 2, 3, 4. Okay, and then I can go back to the vertex, over 3, up 9. So this was 4, so 5, 6, 7, 8. Okay, so it's actually fairly easy after I know that pattern. And again, to get these points, I'm just using the axis of symmetry to help me with that. So this is, oop, there it is. So this one here is, now I should probably label them. So this was number 3, this was number 1, and this was number 2. So if you just go back on yours too, so we have 1, 2, and 3. So it's actually a pretty nifty way to graph. Now you're saying all those parabolas are opening up, Mrs. Brodhagen. I know some of them open down. When you throw things, it goes down. You're right, and we will eventually get to that. So we take our parent, we move the vertex either up or down, and we are always starting with its vertex, and it makes life pretty easy. Now that's just moving up and down. Is it possible to move left and right? Of course it is. So if we think about moving left or right, if you think of your axis that tells us to move left or right is the x-axis, right? X is tells us to move negative or positive. Now the problem is with x. X is such a weird, it's always been bothering you ever since they started introducing x as a number. And unfortunately with it, is when we start moving left and right, it does something a little bit weird on us, which is too bad. Now I'm going to, because I'm going to cheat a little bit, I'm going to clone this parent just to bring it down. And I know that you have to draw yours by hand and you can't clone yours. Too bad, so sad. That's why I'm the teacher. Okay, so I have actually put the parent here. We know the vertex 0, 0. We know our step pattern is over 1, up 1, back to the vertex, over 2, up 4, back to the vertex, over 3, up 9, back to the vertex. Okay, so we know that. So then what do you think would happen if I have y equals x plus 4? 5, I should say. I can't even read numbers. So when I look at this, I can see that they've taken the parent's here, but it's a little bit harder to see the parent. This is squared, so I know that I have an x squared here, but they have this plus 5. So it does something different. And the same thing here, I can see y equals the x minus 2, all of that squared. And as I told you, x is kind of weird. It makes our life a little bit more difficult. And what it does, it actually changes what we would normally think. And you're thinking, Mrs. Brodhagen, what do you mean math has to be so hard? Yeah, I know, I know. So what I'm going to do is I'm going to bring up Desmos just to prove to you what I'm doing is not something that I just made up. So I'm going to pause it and bring up Desmos. Okay, so as I said, I was going to bring up Desmos. So here is Desmos, and you can see the parent is the red. And I have these other ones, I'm just not showing them. So you would think that if we have an x plus 5, that the whole graph would move to the right 5. I mean, that makes sense, right? It says plus 5. And we would think that x minus 2 would move to the left 2 places, so that this whole graph would start over here. But look what happens. This x plus 5 actually moved 5 spaces to the left, which is kind of weird, right? And the x minus 2 moved 2 places to the right. So it did the opposite of what we thought it would do. Okay, so whenever you see that the X has been opened, and often what I tell students, even in grade 11, it's so violent when you have to pull that X away from that squared that it gets it all mixed up, and so it does the opposite of what you think. So however way you want to remember that, but you have to remember that it moves opposite of what makes sense to us. So then when I go and do this now, if I go back to this one, again, I have the parent there, and so let's take a look at this one here. So x plus 5 squared. And I will do it in red. And if you hear some noise, it's because it's near the end of the day and the bell is going to go shortly. Okay, so if you looked at that graph, I know the vertex is -5, opposite of what we thought, and it stayed on the x-axis 0. The step pattern was the same, so the over and up remained the same as before. So it was over 1, up 1, over 2, up 4, over 3, up 9. Now that's supposed to be a 4, and I know it didn't look like a 4. So now if I go to the graph, I'm starting here. Sorry about the bell. Over 1, up 1, back to the vertex, over 2, up 4, back to the vertex, over 3, up 9. And to get the other side, the same thing is true. I use the axis of symmetry to give it to me. And you can see it's the same shape as its parent. It's just the vertex has been moved over. Okay, as you maybe heard, I got interrupted again. So I'm going to do this last example, and then I'm going to, instead of doing a million examples, I'm going to give you a little bit of stuff to work on and see how that works. And maybe you can help each other out with it. So if I look at the last one says y equals bracket x minus 2 squared. Just like all the other ones, my vertex, okay, the x has been opened up. X is always giving me trouble, so it's not really -2, it's +2, and it's at 0. So I'm at 2, 0. Step pattern's the same, over 1, up 1, over 2, up 4, over 3, up 9. And I'm speeding up just a tiny bit because I don't want this video to go over and then have to cut it to make it go into YouTube. Okay, so there's that. And then there's variations of combining the two together. And see how you make out with the work. Don't get too frustrated if it's bothering you too much. Remember, I'm back tomorrow, and it's never the end of the world. It's only math, and it's fun. So have some mathematical pleasure, and I will see you tomorrow.